Since the advent of bezel-less smartphone technology in late 2016, many phones have been introduced with extra tall aspect ratios. Due to this change, the measurement of the diagonal length of a smartphone display has become somewhat useless. For example, the 5.8-inch iPhone X10 has a smaller display than the 5.5-inch iPhone 8 Plus. Curious? Here's how. The iPhone 4 and all its predecessors had 3.5-inch 4x3 displays. The iPhone 5 had a 4-inch 16:9 display. What's notable of the change is that the 5 wasn't any wider than the 4, it was simply taller. If you expand the iPhone 4's aspect ratio by 3, it was 12:9, which means that the 16:9 aspect ratio of the iPhone 5 was an additional 1/3 taller than the iPhone 4. Even though the iPhone 5 had a larger overall display, if it had kept to the 3.5-inch diagonal length, it would have had a smaller display than its predecessor. This is because the diagonal length of a phone's display and its area only correlate according to the aspect ratio. If two phones have the same aspect ratio, then the diagonal length of each is comparable to the other. Between the iPhone 5 and iPhone 8, most phones kept to the 16:9 aspect ratio, which is why any phone with a longer diagonal length was guaranteed to have a larger display. The ideal aspect ratio to maximize area for diagonal length is the square, which is why newer, taller phones have less area per diagonal length. The area of a rectangle is its base times its height. Modern smartphones don't tell you the base or the height of their displays, but you can still find these values with just the diagonal length and aspect ratio. First, you must imagine the display as a triangle which is half of the full display. To find the base and height of the triangle, the first value we need to find is theta, the angle of the triangle. For this, we shall use the arctan function. Arctan is an inverted version of the tangent function, which discovers the base and height of triangles. We will find theta using the arctan of the aspect ratio, then we will use the trigonometric functions sine and cosine along with the diagonal length to find the base and height. The base of the triangle is the diagonal length times the cosine of the arctangent of the aspect ratio. The height of the triangle is the diagonal length times the sine of the arctangent of the aspect ratio. Since area is base times height, we can combine the equations to get area equals the diagonal length squared times the cosine of the arctangent of the aspect ratio times the sine of the arctangent of the aspect ratio. Cosine of x times sine of x can further be simplified with trigonometric identities to sine of 2x over 2, which can be proven with the graphing calculator application. Our final equation is area equals diagonal length squared times the sine of 2 times the arctangent of the aspect ratio, all divided by 2. It's important to note that the equation does not take into account curved corners, curved edges, or notches. With our formula for finding the area of a rectangle using its aspect ratio and diagonal length, we can find the actual size of the displays of all our favorite smartphones, a number that surprisingly won't be found many other places on the internet. Anyways, I hope you found this video informative, and thank you for staying around for the inaugural video of the Bowtie Guy channel. See you next time.